On the previous page, we used an equation to calculate how many t-shirts Marilyn would have to sell to earn $100. And in this example, they show how you can see that same information using a graph. So since Marilyn wants to earn $100, that's what this orange horizontal line is at 100. And then you see where the graph intersects that orange line. So this point right here where the blue line that we graphed and our goal line intersect, that's the point where Marilyn is going to earn $100. And just like in our calculations, at this point, our T is 6.67 and our output E of T is $100. So that's how you can see the same information using a graph. So our goal line is this 100 orange line, and our function or our equation E of T is graphed right here. And the intersection is our solution. So let's see. So in reality, like we were saying, in reality, Marilyn needs to sell 7 shirts. 6 isn't quite enough. So what you're doing now is you're considering different forms that you can use to solve equations and to answer questions and to analyze situations. And 2 of the forms that we looked at are equations and graphs. So here, think about what some of the advantages and disadvantages are of equations and what some of the advantages and disadvantages to graphs are. And you can choose as many options that are true. So there are 2 options here. You're going to choose whichever ones are truly limitations. So limitations means what are some of the kind of like the drawbacks, or why isn't it perfect to use an equation, or when isn't it perfect to use a graph? What are some of the limitations or the drawbacks of equations and graphs? So for example, you have a couple choices for equations. Which one is true about equations? Equations are precise, so sometimes we'll get a result that has too much accuracy, such as fractions of t-shirts, like a result that's 6.7 t-shirts instead of 6 or 7. Is this also true that it's only possible to use positive integers in equations? When we substitute values in to the equation for t, are we only allowed to plug in 1, 2, 3, or could we also plug in fractions and decimals and negative numbers and zeros? And then if you have any other ideas about limitations of using equations, write them here. I don't want you to be limited to these 2 ideas. So choose the one of these that's true, a true limitation of using equations. And then if you have other ideas, I would love to hear more ideas. So type your understandings of limitations of equations. Then think about graphs. What are some limitations of using graphs to solve equations or to look at data? So you have 3 choices. Graphs of linear functions are continuous lines. So graphs will show outputs for non-integer inputs. For example, it won't just show 6 and 7, but it will show all the decimal numbers in between 6 and 7. Another, is this a limitation? It's only possible to see non-negative integer inputs. Is it true that you can only see 0 and up inputs? Or do you also, when you look at a graph, do you also see negative inputs? And then the last choice that you can choose if it's truly a limitation is sometimes it's difficult to read the exact amounts on graphs, especially if you're looking on paper instead of on a graphing calculator like Desmos. So which of these three, and you can choose more than one answer. In fact, you should choose two. So choose one here. Of these options, choose one. And of these options, choose two. Choose the ones that are truly limitations of each type. And then for both, if you have other ideas, please add them here because you come up with incredible ideas, and I would love to hear what your thoughts about the limitations are of graphs and equations. Thank you.